Today's lesson is going to be on surface area and volume, which is our next lesson of our geometry unit. So first, let's talk about some of that vocabulary. Surface area, whenever we talk about surface area, we're talking about covering the outside. So a couple of clue words that could tell us that we're working with surface area are cover, over, wraps, any of those. When we talk about surface area, it's kind of like it's wrapping paper because it goes all the way around the outside of the figure. So our units are going to be squared because that wrapping paper is flat. The way that we write that, so for units, I'm just going to use a U, and then a little 2 up at the top. Volume, on the other hand, is when we fill up a figure. So some of our clue words that tell us that we're working with volume are fill and inside. So for example, instead of wrapping that box, maybe I'm going to fill it up with packing peanuts. So for our units, we're going to talk about units cubed for volume. So instead of a little 2, we're going to use a 3 for that exponent. So now that we've talked about those 2 vocabulary words, let's talk about our 2 shapes that we're going to be using. Our next section is kind of like we're labeling all of the pieces of those shapes and we're seeing our formulas. So on the left, we have a rectangular prism. And some examples that I like to think about to help me remember what rectangular prisms are tissue boxes and cereal boxes. And even though those are different sizes, they're all the same geometric shape, a rectangular prism. So we've got 3 different measurements on a rectangular prism. We've got the height, which we use an H for, the length, which is usually one of those cursive L's, and the width going back. So right here, underneath our picture, are our 2 formulas, and these are extremely important, so I'm going to put a whole bunch of stars here. These are going to be on formula sheets during the SOL, but we have them here underneath the picture for our note sheet. And we'll come back to how we use those in just a moment. On the right-hand side, we've got cylinders. Some examples to help me remember what cylinders are soda cans, so like a can of soda, and also soup cans. So I've got a couple of different measurements here, and they didn't really write out the words, so we're going to kind of put a key on the side here. So H is talking about the height. The letter D, lowercase, we're talking about the diameter. And R is talking about the radius. So you can see that all of these different measurements are labeled on my cylinder, and again, I have some really nice formulas that I'm going to be coming back to a lot. They also gave us a helpful little hint that the diameter is 2 times the radius. So the radius only goes halfway across that circle on top or on the bottom, and a diameter goes all the way across. So moving down to the very bottom of our sheet, this is where our examples are going to be. So I've got kind of one of each. So let's look just at the rectangular prism first. Whenever I get a picture of a shape, I always want to label what's the length and the width and the height. So the height is usually going up top. And according to our picture, our length is here and our width is here. But the nice thing about picking out what all of these numbers mean are that I can turn that tissue box around. So even if I switch those up and I put, for example, the length here and the width here, as long as I use it the same the entire problem, I'm still going to get the same answer. So I'm going to go ahead and use what I wrote down originally. And I'm going to figure out my volume first. And I always like to start out with volume because that seems a little bit easier to me. My formula is a little bit shorter. For volume of a rectangular prism, I have to multiply the length times the width times the height. So the first thing that I always want to do is rewrite that formula And then directly underneath there, I'm going to put the numbers in for the letters that they stand for in parentheses. So instead of L, I'm going to write that number that I used. And in this case, it was 10. Instead of W, I'm going to put a 3. And instead of H, I'm going to put a 4. And now that I've substituted all of those numbers in, now I just have to put them into my calculator. Well, since they're all just getting multiplied, that's really quick. I'm just going to type in 10 times 3 times 4, and I'm going to get 120. And now it's time to look for my units. So those were in inches, so I'm going to keep the inches. And then since this is volume, I'm going to have a cubed up top. All right, let's look at how surface area works now. Surface area takes a little bit longer to calculate, but it's still just as easy. I'm going to rewrite that formula first. So I've got 2LW plus 2LH plus 2WH. And now I'm going to go ahead and substitute all of those numbers in directly underneath there. So I'm going to keep the 2 out front. And then I'm going to put a 10 where L is and a 3 where W is. I'm going to bring down that plus sign just the same. 2, and again, 10 is L, and it was 4 for H. And I'm kind of running out of room here, so I'm going to bring it down to the bottom. And then 2, W was 3, and H was 4. So now that I've put all of those numbers in, now I'm going to do the math. Now for surface area, you got to be a little bit careful because you have to go back to that GEMDAS. And since I have both multiplying and adding, I have to do all my multiplying first before I can add those two numbers together. So that first group that was getting multiplied, 2 times 10 times 3, right there, that comes out to 60. Then I'm going to write down my answer for 2 times 10 times 4, which comes out to 80. And then I'm going to write down my answer for 2 times 3 times 4, which comes out to 24. And now that I've done all my multiplying, I can go through with my adding. So when I add those together, I get 164 inches again, but since it's surface area, it's going to be squared. Now let's take a look at our cylinder example. So just like the last one, I want to start out by labeling what all these numbers mean. I always like to look for the H first, so that height. So that's how tall the soda can is, or how tall my soup can is. So in this case, that's that 4. And then I'm looking, and I only have one other number. So I have to decide if this 10 is the diameter or the radius. And since I have my dotted line going all the way across here, I know that that 10 is actually my diameter. So let's start by figuring out my formulas that I need. So right from right above here, I'm going to do pi r squared h. And the first thing that I'm noticing is that they didn't tell me what r is. So I have to go back and kind of use my clues in my picture. Well, I know that a radius is only halfway across that circle, so from the center out to the edge. So if the whole thing was 10, I'm going to take 10 and divide it by 2 to get my answer. So for this cylinder, my radius is 5. And now I can use that in my equation. Now for our purposes, whenever we see pi, we're going to use 3.14. Now I'm going to go ahead and put my radius in there. So that was 5, and I can't forget to put squared. And then my height is 4. Now we got to go back to that GEMDAS. 5 squared needs to get solved before I can do any of my multiplying. So I'm going to just bring that 3.14 down, change that 5 squared to 25, and bring down the 4. Now I can just go through with my calculator, type it all in, and I get 314. And since this one didn't label what my units are, I'm just going to use a U for units. Remember, volume is units cubed. Now let's look at surface area. My formula for a cylinder surface area is 2 pi r squared plus 2 pi r h. And now I'm going to go ahead and plug in my numbers from my picture. Remember, I'm just going to keep the 2 exactly the same. Instead of pi, I'm going to use 3.14. Instead of r, I'm going to use 5. And don't forget to bring down that little squared. And then I'm going to be adding 2 times pi again, 3.14, times r, which was 5, and then times h, which was 4. Now going back to our Dundas number surface areas where we got to be extra careful, I have to do all of my multiplying first, and even my exponent, before I can do any adding. So I'm going to kind of combine 2 steps. I know that 5 squared is 25, so when I type it into my calculator and I do 2 times 3.14 times 25, I get 157. And then I'm going to do that second part that's all getting multiplied. I don't have to worry about any exponents there. I get 125.6. And now I can go ahead and add them together, which gives me 282.6. Again, we're just going to use a U for units, and since it's surface area, it's going to be squared. So we have an example of volume and surface area for both our rectangular prisms and our cylinders. And the most important piece here is to make sure that you are showing all of your steps. I want to see your formulas, I want to see you substituting in those numbers, and I want to see the math. Even though I used my calculator for all of these calculations, I still had to write down what I was doing each time. So we're going to have a lot of time to practice solving these kinds of problems, but just make sure that you have all of what I wrote up here, every single piece